Hello and welcome to this tutorial on angles in polygons. You might be asked questions about the exterior angles in polygons. Now it's really important to note here that any polygon, no matter how many sides, the exterior angles will always sum to 360. So if we are asked to find the exterior angle of a polygon, exterior meaning on the outside, we simply take 360 and divide it by the amount of sides or angles that the shape will have. In this case, I've got a pentagon. That's a 5-sided shape, so there are 5 exterior angles. Dividing 360 by 5, we can see that the exterior angles of a pentagon are going to be 72 degrees. We can also use exterior angles to help us to find out what the interior angles are, or the angles on the inside of a shape, using another angle rule that we might be aware of, which is that angles on a straight line sum to 180. So I could use the fact that I found this exterior angle to work out what the inside one's going to be as well. The difference between 180 and 72, so the interior angles on a pentagon, for example, would be 108 degrees. We might be asked questions about the interior angles on polygons, and there is a different way that we can find them as well, which I'm going to talk about, and it involves this little bit of algebra. Now, this isn't really anything to be too worried about. I'm going to explain where this has come from. N is the amount of sides in the shape, and to find the interior angle we always take away 2 and times by 180. Let's have a little look why that is. My first shape here, I can see I've got a polygon which is a triangle. Now a triangle has 3 sides. There is only one triangle, and we are aware, or I hope we're aware, that the interior angles of any triangle will sum to 180 degrees. We can use this fact to work out the interior, or the sum of the total interior angles on any polygon. We can take the corner of one of our shapes and join the other corners up. Now there's not really any point me drawing a line here because it's the side of the shape, and the same here, but I can draw across this diagonal, and what you might notice is that I've split my quadrilateral in this case into 2 triangles. So my 4-sided shape has 2 triangles. We know that the interior degrees of a triangle are 180. So 2 times 180, the interior degrees of a quadrilateral are 360. And we might already have known that. Let's have a little look at this 5-sided shape, this pentagon. Again, there's not much point me drawing this line here because it's the side of the shape, but I am going to just join up this corner. I've always got to go back to the same one. I can't just sort of randomly start joining up the different corners. I've always got to go back to the same one and join up all of the corners. And we can see now that I've got 1, 2, 3 triangles in this pentagon. 5 sides, 3 triangles, 3 lots of 180. The total of the degrees on the inside of this shape, 540. Taking my hexagon, my 6-sided shape, and doing the same thing, I can see 1, 2, 3, 4 triangles, 4 times 180 for an interior degree total of 720. And you might have noticed, or starting to notice, that for however many sides we've always got 2 less triangles. Okay, and this is where this portion has come from. So we take the amount of sides, take away 2 and multiply by 180, and it will find you the interior degrees in a polygon. You might be asked questions like this in your exam. The diagram shows a regular hexagon and a regular pentagon. This is my pentagon, my 5-sided shape, and this is my hexagon, my 6-sided shape. And we've got to work out the angle X. Now there's a couple of different ways we can go about doing it. I'm going to show you both of them, and one is to use the method for finding exterior angles to help us to solve it, exterior, and the other one will be using our interior angles. So I might notice that these two shapes are sort of stuck together here, and I could actually carry on this line that they share and split, it's a really badly drawn line, and split this down here, and I've got the exterior angle of my polygon here and the exterior angle of my hexagon. Knowing that now we know that the exterior angle of any polygon is 360, I can find the exterior angle of my pentagon by saying, well, I've got 5 sides, therefore 5 exterior angles, and dividing 360 by 5. 5 goes into 36 7 times, with 1 left over, and 5 into 10, 2. So the exterior angle, 72. Doing the same now with my hexagon, remembering that no matter how many sides my shape has, the exterior angles are always 360. This time I've got 6 sides, therefore 6 exterior angles. 6 goes into 36 6 times, bringing the 0 up for 60. So my exterior angle of the hexagon, 60. And then I've just got to add the two together for 132 degrees. So X is 132 degrees. The same question now, but we're going to answer it differently using what we know about the interior degrees. Let's look at our pentagon first. We know that a pentagon has 1, 2, 3, 4, 5 sides. So we know it's going to have 2 less triangles. 3 times 180, because that's how many degrees there are in a triangle, means that the total interior degrees of my pentagon is going to be 540. Dividing this by how many angles I have on the inside of my pentagon, 1, 2, 3, 4, 5, I can figure out what the interior angle is going to be. 540 divided by 5 for 108 degrees. So this inside angle, 108. Let's look at our hexagon now. I've got 1, 2, 3, 4, 5, 6 sides, so I'll have 2 less triangles. 4 times 180 for an interior total of 720 degrees. Looking for this angle here, but I can see I've got 1, 2, 3, 4, 5, 6 angles in total on the inside. So splitting my 720 degrees evenly between the angles will give me 120 degrees. This inside angle, 120 degrees. You might also note that all of the angles that we've now got are around this point here. Angles around a point sum to 360 degrees. So I can add together my 108 and my 120 for 228 and take it away from 360 to find my missing angle. X is 132, which we already know from the previous question. So 2 different ways of solving it. I personally think that the first way we did it was less involved, but if you get into your exam and you're happier solving it the second way, then that's good enough to get you full marks on the question.